Okay, radians. Second video on radians. This is chapter 5 from the year 2 A-level maths book by Pearson. This time we're going to look at the length of an arc, and we're also going to look at the area of a sector and the area of a segment. Okay, so we're looking at the length of this part of a circle if the angle subtended at the centre is theta and the radius is r. Well, back in year 11, perhaps year 10, when you were dealing with degrees, your formula would have been, so arc length would have been theta over 360, so this angle divided by the complete circle, times by the length of the circumference, which is 2 pi r. Well, if we're dealing in radians, then this thing can't be in degrees. We need to have it in radians, and as we just learnt from video 1, a complete circle is 2 pi radians. So theta over 2 pi times by 2 pi r. And I'm sure you can see, well, they just cancel. So the length of an arc using radians is simply r times theta. So the length of an arc is r times theta. And sometimes, of course, you'll have to find the length of the arc given the angle. Sometimes you'll have to find the angle if you're given the length of the arc. And of course, you could also have, well, if you know the length of the arc and you know the angle, how do you find the radius? And this is the formula that you're using. I don't think I need to go through a particular example. It is as straightforward as that. It's even easier than what you learnt at GCSE. The area of a sector works in a similar kind of way. Area of a sector. So that's the area of this slice here. And at GCSE, this is the formula you would have used. So it's theta divided by 360 times by the complete area. So pi r squared. But we're dealing in radians. So once again, this is not 360, this is 2 pi. So I've got theta over 2 pi times by pi r squared. And I'm sure you can see that the pi's can cancel. So I'm left with theta over 2 times r squared, which you often see written as half r squared theta. So the area of a sector is half r squared theta. And once again, it's a straightforward formula. There's lots and lots of questions. I think it's exercise 5b, could be 5c, and they get harder and harder, but essentially this is what you're using. They've also got some questions which deal with the area of a segment. Now, a segment, as you'll remember from GCSE, is this area here. And as with GCSE, we find it out by working out the area of the sector, the whole slice, and we take away the area of this triangle. And we're not going to use the year 8, year 9 area of a triangle. We're going to use the formula we learnt in year 10 or 11. So just as a reminder, the area of a triangle is half AB sine C. That is for any triangle where this angle is in between these two lines. But of course our two lines are both r. So for our triangle that's inside a circle, half r squared sine theta. So the area of a segment is the area of the sector, which we've got here, half r squared theta, take away the area of the triangle, half r squared sine theta. Now I'm sure you can see that this simplifies. We can factorise, we can take out a half r squared, so we've got half r squared theta, take away sine theta. That is the formula for the area of the segment. Once again, the maths is not very difficult. Some of the questions get really quite complicated, but not because of the fact we're dealing in radians, just because of the fact that they're tricky questions. Okay, that's length of an arc, area of a sector, area of a segment. I think that's exercises 5C and D. I'm not certain. Have a look.